Welcome to this live session. This is the first live session of a series that we are going to hold here every Monday. Hopefully, the next time we will start right on time at 20 p.m. Brazilian time. Well, this time we started a little bit later, but my name is Antonio. I'm the creator of the FatScript language and its interpreter. I am a software developer, and FatScript is my personal pet project, my a thing that I have dedicated almost the last 2 years of time I had, like that I was able to spare and spend and invest in creating this cool language. At least I find the language super cool. So let's talk a little bit about what we are going to explore today. Today I wanted to show you how to use the benchmark section of this project, and to my surprise, FatScript actually did perform quite well when compared to JavaScript and Python. I was not expecting this result, to be honest. I was expecting it to underperform considerably when compared to these two other languages, because they are much older. They have had much more investment in time and effort to get where they are now today. Of course, they also do implement a lot more features than JavaScript, than FatScript. JavaScript and Python do implement a lot more features than FatScript. So the comparison is somewhat fair to some degree. We are going to use a tool called Hyperfine. So this is the tool we are going to use, Hyperfine. Yeah. So you can look it up in Google. I'm not gonna get much into the details. It basically helps us to see the performance of a task, of a program you run. And the first program we are going to compare here is the factorial program. I actually have increased for this example for this session from 25 to 100. It's gonna compute the factorial of 100 in FatScript, which is basically this function. It will also print how much memory it takes. We're gonna do the same for JavaScript and then Python. I have created a little script here that will run all these programs with each of the corresponding interpreter, and also will print the time it takes. And we're gonna do this first, and then we can do the one with the Hyperfine. Okay, so just for you to get a rough idea of how this will behave. So let's just remove this, expand this, and now I'm gonna run benchmark run all. So you could see there that the Fibonacci one took quite a while to execute in FatScript. Mostly, here you have, like, for example, for the factorial one, it took 45 seconds, 45 milliseconds. It used 32 megabytes in JavaScript. For Python, this was almost 9 megabytes. For FatScript, was almost 8 megabytes. So this was the most efficient memory-wise, and also from the performance-wise, it took just about 6 milliseconds. So 14 milliseconds for Python and 45 milliseconds for JavaScript. Though I think that JavaScript takes a long time also to start because of how big it is. So that's might not reflect 100% the efficiency of the code being executed. But I must say that if you're doing like little tasks, definitely FatScript is the one that starts the fast out of the three. It will start much faster. It will have a much better response time for small tasks. That already can be seen here. Also, the footprint for the memory is actually better in this particular case. Now, we do have a very bad one for Fibonacci and FatScript. Now, FatScript, when running Fibonacci, just made almost 600 megabytes, so 0.6 giga in RAM usage. That's a lot. It was also horribly slow. It took like 1.6 seconds to execute Fibonacci, and then we had like a much better result with JavaScript, which was the fastest one, and then in second place Python. However, the memory can be much more efficient. The biggest problem here is the stack usage. So I did create another example for Fibonacci, which is kind of this way of doing it, like the recursive way. Let's look at the code. So if we look at Fibonacci, this implementation, which is the recursive one, just basically creates two calls each time it reaches here. So this is like a growing tree. It grows all the time. Each time you get to this line, it's gonna double the space in stack. For sure, there must be some optimization for JavaScript and Python. They're surely doing something more clever than FatScript is doing on its process of interpreting. But yeah, I must say, FatScript really loses that one by a lot. But then when you do the writing, like JavaScript does have a memo way of doing it. You can just create an object and then you use the closure to just basically reuse that memo to, like store the values in between that you use. And you can also use the RU cache from functools to memorize a function in Python. And then also we have also a memorization tool in FatScript. Now, the interesting thing about this is I'm doing memorization on all of them, so it's a fair comparison. And when they are memoized, then you see that FatScript actually shines because it's like 1,000 times faster, and it's the one that uses the least amount of memory, and it just performs much faster as all of them. So yeah, that's a kind of impressive thing that I was not expecting. Then we do have a parsing example as well, which basically creates a list of objects in JSON, like a string. Then we parse that, and then we create a new string from it. And here, when we see the result of the execution of these three, you can see actually that the winner is Python, but FatScript is not that behind. It is almost double the time of JavaScript. It's not very efficient on the memory. The other ones are kind of a little bit better, but overall it's usable. It's not like impossible. It's just twice as slow as JavaScript for doing JSON operations. So considering that how much effort was put into putting JavaScript and optimizing JavaScript for JSON, I'm actually feeling great about this. I think FatScript is quite efficient, and maybe there is opportunities to still improve more on this one. For string concatenation, what we do here is we just concatenate 100,000 times the word hello on itself. So we go and start with an empty string, and we concatenate it on JavaScript as well, and Python as well. And here, surprisingly, Python is the one that gets really bad. It takes like 5 seconds to concatenate it. I don't even understand how it can get so slow. And here actually for string concatenation, FatScript does win this round. And for summing a list of numbers, we also create a list of numbers which goes from 0 to 99,999, which we do on all of them pretty much the same way. Yeah. And then we just use the sum function for both Python and FatScript. And because there's no sum function on JavaScript, we use the reducer, which is kind of the second best option to do it. Maybe we should have used reduce on FatScript and reduce on Python to be a more fair race. Anyway, maybe I'll implement it in a second option, like all of them using reduce just for the comparison. But if you see here, we basically have Python having the best implementation for the sum, and then slightly behind we have FatScript, and JavaScript is definitely way slower, like almost twice the time it takes for Python to do the summing of this array of numbers. And also the number, like the 40 megabytes of RAM space is also something where it's also not shining. I mean, in this one, definitely Python has the edge. I'm going to run the hyperfine version of it because it's more precise regarding the timings, and we can see definitely for the performance which one is the winner. So I'm going to put race all, which is a script which will run the hyperfine tests. It does a warm-up of like two rounds of warm-up for each case, and then it executes at least 10 times the same test over and over again, just to make sure we are like having a proper measurement of those results. Another thing, while this test actually executes, I'm going to show one more thing about this, because hardware can influence. So I'm here using just so you know, this is a reasonably powerful machine. It's using 13th generation Intel i7. I have downclocked it to 2.6. The original clocking is at 5 gigahertz, but I thought it was running just too hot, and so I downclocked it. And it has also a lot of RAM, so we're not even touching, not even scratching this RAM. And yeah, that's basically it. Also, regarding the versions, Fry here at this point is at version 3.2. Node version, I might be using a slightly older version, which is the 1421. It's maybe not the latest, but it's definitely also not too old, I think. And for Python version, I'm using 3.12.4, which is definitely one of the latest versions out there. So yeah, basically that's the ones, that's the versions we had. That's the hardware I'm running it. This benchmark. Maybe this will perform completely differently on a Mac or on another kind of ARM machine. I honestly have not seen this being much. I have a Raspberry Pi here. I remember running this code. It was not that much different of what we saw on an Intel machine. So I'm not sure if I think the implementation and the algorithms that actually run on each of these interpreters is what makes the most impact out of it. Yeah. Anyway, so let's look at these results here we got. So for the factorial one, Fry, and so consequently FatScript, was 2 times faster than Python and almost 6 times faster than Node and JavaScript. So that's actually impressive. And I attribute this to how fast it can start. Like from code boot to running the code, it's really, really fast compared to the other two. Then When we have here Fibonacci one, then definitely we have a big loss for for FatScript. It's the winner here is Node. Python is about 2 times slower, and then FatScript is almost 32 times slower. However, with the memoized version, like the one that does take advantage of the language features, now if you look at it again, Fry is actually the best one to run Fibonacci with memoization. So if you use the memoization function for anything that actually can benefit from memoization, maybe you're gonna get the best out of FatScript after all. So it's shockingly faster than both of them, and even as itself, in comparison, it's 1,000 times faster. Um, However, the explanation I think that could be here, I'm not sure that there is actually some tail call optimization for JavaScript and for Python, but I do think that there must be something around these lines. Now, FatScript does implement recursive tail optimization. So but it doesn't apply to Fibonacci, because Fibonacci does have a computation in between. So it does one call and then the other, and then it sums the result. So it does not get automatically optimized in the case of FatScript. There is a section in the web page, like in fatscript.org. You can visit it, and there is a section which explains about how to properly use tail recursion on FatScript. But these ones this function cannot benefit from it. So that's why it basically performed really bad. JSON parse, Python one wins this one, and actually quite a little bit in comparison. You would expect that actually Node would win this one, because like JSON, it's like the JS object notation. I don't know. Anyway, but Python is actually better at it than JavaScript, surprisingly. And Fry loses this race, but I mean, it's still fairly reasonably fast. You can definitely use Fry for using any tasks that involve JSON parsing and or outputting. I think that actually the parse part of it is a bit slower. The output, like when you generate the JSON, is actually fast, very fast. So maybe it's even, if we had benchmarked those two separately, we could actually see if one thing is faster, the other thing is slower. Anyway, we can actually do that. Let's do it. Just a quick check. So if I don't do these two things, and yeah, here I'm just gonna print what is the size of the object, right? So now I think there's no other way I can actually do this unless there's no way. Like, let's just see how much of that is actually the parsing part. So that's for sure something we can see here. And then like I'm removing the part where it converts it into a string. I just want it to count how many objects it has in there. So let's see also on the JSON parse, if I don't do the stringify, and then I just want to see the object. I'm not even sure if you can do object length. I think we can. It's not a 100% sure thing. And then here also we're also gonna see the object length. I might be mistakenly trying to do this. Maybe this won't work, but let's just do the JSON parse race. So yeah, I don't think that the times did improve a lot. Um, they are smaller. The numbers are smaller for sure, but basically the ratio is very close to what it was before. Um, for the string, for the JSON parse, which was 1.2, yeah, the time was 100 milliseconds for Java, for FatScript before. Now it drops to 87. It's just a minor gain. Like, definitely the worst part of it is parsing, is not generating the output, and still the it really shows here that the Python is the fastest one. Anyway, I think this was just to give us an example here on this. And then the string concatenation, we already went through this. The list, summing, we went also through. So I think that basically we saw all these examples here um, on how these languages compare to each other in terms of code and in terms of performance. Like, I tried, the interesting part of this is also you can just look at how the syntax of each language kind of looks like. Some of them are neater in one language, some of them are neater in another language. For example, the Fibonacci one, it does look neat, a lot neat in FatScript, but then it doesn't perform that great. But if you do have the option of doing it with a memoization, and then it does perform really great, better than the others. So yeah, like string concatenation. Here we are doing it with a for loop, which is not very pretty. But for the parsing function one, we are using repeat here and repeat here, and this one also uses some sort of repeat, which is times 10,000 here. So yeah, basically each language has its own way of doing things, but as you can see, they're quite similar in some sense. And I think that that's the point I wanted to make by bringing this content here today was to show that FatScript is actually a viable language. Like, it's not that far off from other major languages that are being used. I'm actually quite impressed with this outcome. When I saw this, I was not really expecting that FatScript would perform that well in comparison to these two other languages. And especially because they are backed and they have a lot of by companies, they have like a lot of investment. This is a personal project, so even the fact that even if it was like 1/5 of the performance of each of those languages, I still would be kind of happy that it even compares in some sense. But the fact that it even wins in some cases, this was really amazing for me. And then there's another thing which I must say, which is FatScript does implement a lot of cool features that are not available on these other languages. So FatScript, its roots, like the reason why I did it and how I did it, comes from like taking ideas that I like about different languages and trying to mix them together. So it does take some inspiration in Scala. It does also take some inspiration from from JavaScript and from Python as well, that I do like. I tried to put in the features that I like the most. I tried to avoid the features that I hate the most. And of course, some will agree and disagree of what are the best features of and the worst features of each language. So but the FatScript, for example, does have natively type checking, so you can do all of these code. It's actually performing type checking when you're running it in an even more strict way than Python, because Python does have some type checking, but it's a little bit loose. It's not so strict. And you can also let your hands a little bit looser on FatScript if you want. It can handle any type, like JavaScript, which everything is any. You don't really know the type until you actually pass in an argument. But functions can have type checking on each parameter in FatScript, and that actually does add a lot of safety to the language, which is a very cool and very interesting feature. And so I do think that projects actually in FatScript could scale much better than in other languages. But of course, for example, Python does have a very incredible backend integration with the Boost library that gave it all these integrations with all the dynamic loaded libraries. And I'm currently working on getting even some very basic foreign function interface into FatScript. This is not yet released, but even when it's there, I'm not expecting it to be as good as it is currently with Python. But maybe if I keep on working on it, it will actually get as good or even better. I don't know. I was surprised by how the performance actually got better over the time while I was developing FatScript, and now it's actually it's on par with those other languages, I would say. So yeah, there is good reason to show this to the world, because maybe there is features that would be on this language that would actually shine if the performance is not a reason why you would discard it, So yeah. Anyway, I hope you enjoyed this video. I hope you could learn also a little bit about how to benchmark your scripts, your code, and these kind of sessions we are going to talk about tools like today I shown you Hyperfine, how to use Hyperfine, and different tools, of course, we're going to see for working with your code, with scripts, scripting. We are probably going to do something more useful, like get our hands dirty, like really writing some FatScript code. Today we were more just like looking at how the code was already implemented. You can git clone this and have your own go through this code if you like. Just look at fatscript.org. Don't forget to subscribe to FatScript YouTube channel, because we are going to have this meeting here every Monday. So I hope if you have any questions, just put down below on the comments. And I hope to see you on the next session, which will happen next Monday. So that's it for today. Bye-bye. See you. And I'm gonna end the transmission now.